So the first step is normality test. And from here on, whatever test we perform, we need to compose null and alternate hypothesis. Null hypothesis says take no action. Alternate hypothesis says take action. If data are not normal, what do? We transform the data. So we take action if data are not normal. Okay, so if data are not normal, we take an action. And when do we do not take an action or follow the status quo? When data are normal. You need not transform the data if data are normal. All right. Now we need to perform this normality test. I already have this open, this Minitab file open, so let me traverse and see whether I got it right. No. This is, yep. So we have the fabric length of 25 data points. Right? So we have 25 samples of the fabric that were randomly taken, okay, which were randomly taken from the various things which were manufactured. In order to test the normality, all we need to do is go to Stat, Basic Statistics, and here you have an option called Normality Test. We click on that. Fabric length. So if you do not see anything here, that means you haven't clicked in this box. The moment you click, you would see the fabric length. So there we go. We have the fabric length. We are not concerned about any other value at this point of time. Usually, we perform Anderson-Darling test to check whether data are normally distributed or not. If I click on OK, you will get a normal QQ plot, quantile plot. If you look at the data, if majority of the data points fall along the line, we say that data are normally distributed. However, we also need to look at the p-value. P-value here is 0.205. So when do we take an action? We take an action if p-value is less than 0.05. What does that indicate? If the p-value is less than alpha, in this scenario, if p-value is less than 0.05, it implies that there is less than 5% chance that you would go wrong if you take an action. But the p-value in our scenario happens to be 0.205. So 0.205, which is of course greater than 0.05. It implies that P is high. So here is a slang that you need to remember from here on. P high, null fly. That means if P value is greater than 0.05, we fail to reject null hypothesis. In layperson terms, we accept null hypothesis. So we fail to reject this. Null fly, that means data are normal. Yeah. Now, we have found that the output variable fabric length is continuous and the input variable is discrete, one population. So we looked at this on whether we are comparing one population with external standard. Oh yes, absolutely. We are comparing a single value with the historical data external standard, which is 150 mm. Are data normal? Oh yes, data was shown to be normal. If data are normal, the next step is we need to ask ourselves on, do we know the population standard deviation? Do we know that? Now, if we go back to the problem statement, the standard deviation is provided as 4. This is population standard deviation, right? It's provided to us. Historical data. We are assuming that there are only 2 years data available, so we have taken that. It's 4. So we have taken that as 4. Now, since we know this, since it is yes, we proceed with one sample z-test. We proceed with one sample z-test. So now we need to perform this one sample z-test. Let us do that. So we are done with the normality test. Okay, we're done with the normality test. Let me erase everything. We check whether population standard deviation was known or not. And we came to know that population standard deviation is known. If the population standard deviation is known, we need to proceed with one sample z-test. Okay. In this one sample z-test, the navigation is provided. Even for normality test, navigation of Minitab is provided. Okay. So the second thing is we need to perform one sample z-test. One sample z-test. Any test that we perform in hypothesis, we need to first write down what is null hypothesis and what is alternate hypothesis. Null, alternate hypothesis. Say we want to take an action if the average or if the fabric length is greater than 150. Say you want to take some action. Maybe replace your machines, get the surveys done, or do whatever is required. And say your average, and you do not want to take any action if the average fabric length is less than or equal to 150. So once we compose null and alternate hypothesis, we need to perform this test. And the navigation required to perform the test is already provided here. One sample z-test. Stat, basic statistics, one sample z-test. So in order to go back to your worksheet, all you need to do is click on this. Just click on that. You'd come back to your worksheet. And once you come back to your worksheet, you need to go to Stat, Basic Statistics, one sample Z. And here, one or more samples each in a column. Yeah. And there is nothing here. Until and unless you click in this, you'll not be able to see this. So I select that, fabric length, say okay. Is a standard deviation known? Do we know that? Oh yes, we know that. It is provided in the problem statement that it is 4. And do we have a hypothesized mean? Hypothesized mean is provided as 150. So these details are provided to us. Now you can click on options and check what is your alternate hypothesis. Our alternate hypothesis that we have written here is greater than 150, right? It's not the default option. So it's greater than. So I'll change it to greater than. I'll click on OK. And do you want to see any graphs? Say you want to perform a histogram. I wish to explain you all the importance of histogram in this scenario. So let me click on OK and we are done. I'll come back to this histogram. First, let me explain about, let me do this. So look at this p-value here. The p-value which is provided is 0, 0.000. That is what is calculated. It is almost 0 there. So p-value is equal to 0, which is obviously less than 0.05, which implies P low, null go. P high, null fly. P low, null go. So that means you're going to reject null hypothesis. The moment you reject null hypothesis, null go, you reject null hypothesis, you'd be left with alternate hypothesis. So your alternate hypothesis says current mean is greater than the historical mean. So you need to take some action. You need to probably rectify your machines, schedule some kind of, service on your maintenance on your machinery basically. We can also look at the histogram and try to make sense here. If you look at this line here, the blue line, this is your 95% confidence interval, which shows the range where the true population mean may lie. Okay, and if you see this value here, that's the average. And since this H0 is outside, if you look at the H0 value, it is outside this confidence interval. This also is another way to say that H0 is rejected. We reject H0. Why? Because it's not falling within this interval, confidence, 95% confidence interval. This is another way of just looking at your histogram and taking a call. All right. So if I go back here, so what do we conclude here? We conclude that the current mean is greater than historical mean. We go and provide the statement to the management, and management can take a call on what do they want to do, right, provided this particular statement. Now we will proceed on and on with a few more case studies, and we will try to understand more.